All right, welcome. In this video, we're going to talk about how to convert NFAs to DFAs and DFAs to NFAs. The first one that's easier is how to convert a DFA to an NFA, and then a little more complicated is how to convert an NFA to a DFA. If you remember from the last video, I did say that if there exists an NFA for a language, there also exists a DFA. Or if there exists a DFA, there also exists an NFA. And what class of languages are DFAs and NFAs? They are the class of regular languages. So we can say that a language is regular if there exists a DFA for that language. And also, if there exists a DFA for that language, there also exists an NFA, and vice versa. So let's get started. First, we're going to convert a DFA to an NFA. The easiest way to convert a DFA to an NFA is to take the DFA and just convert it to an NFA with only one accepting state. Okay, it's still an NFA, and that is the easiest way to do it. It takes 3 steps, and the name of this procedure could be called Convert DFA to NFA, but I made up a name and I'm calling it Procedure Bob. Only in this class will we know what Procedure Bob is, and if I say Procedure Bob, you should know what I'm talking about. That means to convert a DFA to an NFA with one accepting state. Don't confuse this with Procedure Mark. That's something to reduce the number of states. Procedure Bob is just a made-up name. If you don't like to use Procedure Bob, this is called the procedure to convert a DFA to an NFA with one accepting state. Okay? All right. So the first step in doing this is to make the DFA accepting states no longer accepting. So take a look at our DFA here. We have all of our transitions defined for all of our symbols for all of our states. And Q1, Q0, Q1, Q2, and Q3 are all accepting. So step 1, make them all not accepting. Step 2, create a new accepting state. So we have created a new accepting state. And then step 3, add lambda transitions from all the previous accepting states to the new accepting state. Again, this is going to be the same as the original DFA. The original DFA was just Q0, Q1, Q2, Q3 were all accepting, but now I have changed them to non-accepting and added lambda transitions to a new accepting state. This is now an NFA. Convert a DFA to an NFA with a one accepting state, and I have a made-up name in which I call that Procedure Bob. All right. So now here it gets more complicated. If you have an NFA and you want to convert it to a DFA. If you remember from any of the previous videos, we had NFAs that became pretty complicated. So if you want to convert an NFA to a DFA, there are a couple of techniques. There's also a theorem that says if there's a language that is accepted by an NFA, then there exists an equivalent DFA. I already said that, but now I'm just saying it as a theorem. All right, so this is the construction technique to change it. Convert an NFA to a DFA. All right, so first you have to create n number of states that is the power set of the ones in the NFA. So if your NFA has 3 states, your DFA is going to have the power set. So you're going to have the empty strings. You're going to have Q0, Q1, Q2, Q0, Q1, Q0, Q2, Q1, Q2, and Q0, Q1, Q2. All right, then you're going to label all states with the possible sets of Q from the NFA. So some of them, they're going to be labeled. So you're going to take your NFA and then you're going to create, I'm going to have an example because just saying this just sounds very, very confusing, but once you do it and you practice it, and you'll have an exercise in which you practice it, it will be much more clear. So then you're going to label all your states. You're going to pick your initial state. Your initial state has to include the initial state from the NFA, including any lambda transitions. So if you had you have your initial state as Q0 with a lambda transition to Q1, then your initial state would be Q0, Q1. Okay, so then you just continue to check for all states with transitions coming in and without transitions going out, and you have to do that for all symbols of the alphabet, and you continue to do that until you have completed and gone through all of your power set. And then any state that was accepting, so if, for example, here, if Q1 was accepting, then here we would have Q1 accepting, Q0, Q1 would be accepting, Q1, Q2 would be accepting, and Q0, Q1, Q2 would be accepting if they are all valid states in our DFA. All right, so now let's get started. All right, so let's get started converting an NFA to a DFA. This is can be kind of complicated, but let's just take it one step at a time. Take a look at this NFA. It has 2 lambda transitions. So it's we got to take that into account, and it has 4 states. So the first thing you want to do is create the power set. So we've created the power set of all the states of this NFA, and now we're going to figure out what is our initial state. Well, on the NFA, the initial state is Q0. However, if you notice, we have this lambda transition here, so we have to include Q1 in our initial state. And we have another lambda transition here, so we have to include Q3 in our initial state. So our initial state is actually Q0, Q1, Q3. Now later you can rename this when you have your DFA, but for right now, to keep the relationship and to keep things clear, we will keep these names on our, and they should actually on our states. Okay, so now that we have marked our initial state, Q0, Q1, Q3, now we have to check where we can get from Q0, Q1, Q3 with a 0. So from Q0, Q1, Q3, you have to also take into account the lambda transitions. From Q0, we can get to Q2 with a 0. From Q0, we can get to Q1 with a 0. And we can also lambda transition down to Q3. So we have to also check Q1 with a 0, we can get to Q2. And Q3 with a 0, we can get to Q2. So from Q0, Q1, Q3 with a 0, we can get to Q1, Q2, Q3. What about a 1? If we are in Q0, Q1, Q3, where can you get with a 1? Well, from Q0 with a 1, nowhere. From Q1 with a 1, nowhere. And from Q3 with a 1, nowhere. So that is just going to take us to a trap. So we don't need to define that transition because it's not going anywhere. All right, our next one, from Q1, Q2, Q3, Q1, Q2, Q3, where can you get with a 0? All right, so from Q2 with a 0, nowhere. Q1 with a 0, you lambda, you get back to Q2. So from Q1, Q2, Q3 with a 0, you would get back to Q2 and Q3 to Q2. So this is correct. From Q1, Q2, Q3, you can get to Q2 with a 0. From Q1, Q2, Q3 with a 1, Q1 with a 1, nowhere. Q3 with a 1, Q2 with a 1. From Q1, Q2, Q3 with a 1, you can get to Q1, Q3. So we have that. With a 1, you can get to Q1, Q3. That is correct. All right, so now we have transitions going into Q2 and transitions going into Q1, Q3. So we have to continue until we no longer have any going in and none coming out. So the next one, I'm not sure which one I did next, so let's check. All right, so from Q1, Q3 with a 0, you can get to Q2. And then we just have to check from Q2 with a 0, nowhere. And from Q2 with a 1, you can get to Q1, Q3. So now I believe we have, since Q1, Q3, and Q2 go back to each other, I believe we have now continued with all the transitions coming in. We have defined all the transitions going out except for the ones that are not defined. So now let's make a little table of that and rename. So Q1, Q0, Q1, Q3 I have renamed to be P0. That is our initial state, right? So then you look, Q1, Q3, Q0, which is our initial state right here. Out of Q1, Q3, Q0, Q1, Q3, are any of them accepting? Q0, yes, Q3 is accepting, so therefore P0 is going to be accepting. Okay, then from P0 with a 0, it goes to Q1, Q2, Q3, which we have renamed to be P1. So from P0 with a 0, you're going to go to P1. Okay, P1 is actually Q1, Q2, Q3. So that one is also accepting. And then with a 1 from P0, you're going to go to the trap state because, oops, the P4, because we did not define what to do here from, and I can actually like right here, so this is P0, this is P1, and this is P2, and this is P3, and then P4 is our trap state. So all I did here was just redraw this one that I had down here in a little nicer way over here. If any of them, that's why you keep this to remember, if any of these are accepting, then it's going to be accepting. If any of these are accepting, it's going to be accepting. If any of these are accepting, it's going to be accepting. And any of these are accepting, it's going to be accepting. So all P0, P1, P2, and P3 are all accepting. And the ones that are not accepting, of course, is going to be P4 because that's the trap state. So these slides are posted for you, so you can, after watching this video, you can go back, rewind the video, try again, and I will give you exercises to practice. If we want to try a string, let's try a string that's accepted. So here's a string that's accepted, 0, 1, 0. So we have one string, 0, 1, 0, that is accepted. So we try it in our NFA, 0, 0, 0, 1, 0. Yep, it's accepting. So pretty much this should be an equivalent DFA to this NFA. And you can take a bunch of strings and try them and see if they are accepting. And maybe try to come up with what this language is. This is an exercise to convert and see if you guys know what this language is. All right, so here, this is a little bit neater without the power set. So now this is just another slide. It's the same thing. And you can practice and see if this is a correct representation of that. Well, let's see if you get just a 0. Yes, it's accepting here and it's accepting here. So keep in mind that in NFA, you could do just a 0 and end up here not accepting. But then even if you did just a 0, you're going to jump here to accepting, or you could do just a 0 and end here accepting. All right, so now let's try converting an NFA to a DFA with the chart method. So here's the chart method. All you do is you make a chart and you list your states, and then you list, you separate the lambda transitions, and then you're going to combine the lambda transitions after. So let's start first From Q0, with a 0, you can get to Q1, Q2. With a 1, you can't get anywhere. And with a lambda transition, you get to Q1. From Q1, with a 0, nowhere. With a 1, nowhere. And with a lambda transition, you get to Q3, Q2. With a 0, nowhere. With a 1, you go to Q1, Q3. And Q3, with a 0, you get to Q2. Next step, get rid of the lambda transitions. So you're going to have to combine Q0, right? You can jump to Q1, which takes you to Q3. So now from Q0 with a 0, you can actually get all the way to Q1, Q2, Q3. And from Q1 with a 0, because of the lambda transition, you can get to Q2. And from Q2 with a 1, because of the lambda transition, you can get to Q1, Q3. Right? So this is step 2. Then step 3 is you create your new states. So we're going to create our new states for our DFA. So you look at the states we have created here. So what states have been created? We have a state that's been created called Q1, Q2, Q3. We have a state Q2. We have a state Q3. And we have an empty state. And we also have to have our initial state. So you're going to have to create your initial state, plus you're going to have to create your other states. So we make P0 is going to be our initial state. Our initial state is P0. And then we create a state out of Q1, Q2, Q3. So P0 is initial. Then this is P1. And then P2, this is P2. And then this is P3. So once you do that, then you can use the chart to help you to say from P0, where can I get to P1? From P1, where can I get with a 0 and a 1? From P2, where can I get with a 0 and a 1? And from P3, where can I get with a 0 and a 1? And then you just draw the DFA, same DFA that we had from the other one. So that's a different method. You can either use the power set method or you can use the chart method. Let's take a look at this one. So here's one. This NFA has 1, 2, 3, 4, 5 states. So doing the power set method, the power set method for this is a lot of states and can become, this is alphabet A and B obviously, but the power set can become a little bit complicated, but this is another example if you guys want to try it and check it and see if I'm right. But I think I'm going to do the chart method for this one. So with the chart method, again, of course you have to do your initial state, but now we have Q0. Where can you get with an A or a B and a lambda transition? All 5 states. Then you just go to the next step, get rid of the lambda transitions, then go to the next step, create your new states, including your initial state, and create this chart. So this is chart 1, this is chart 2, and this is chart 3. The chart method, it depends, on how you want to do it. If it's only a few states, then the power set method might work, but I think that the chart method is a little bit neater, and so you guys can review this and see if this is going to convert this NFA into this DFA.